All right, should be good now. Let me just make sure I can hear myself. Testing, testing. All right. Open. All right, there we go. So, welcome everybody. I'm just going to do a quick one here today. So, I had a lot of fun with my new computer making shorts. And so I just wanted to show you guys what I did. I made a short out of about 23 minutes of material and I made it into 1 minute. So here, I shall show you. We're going to make Phobos, Mars's moon, the size of our moon. So we're going to go to all planets and all moons first. Make sure that you guys can see this whole universe sandbox screen here. Okay, so we're going to go into Mars. All right, so pause. So Phobos is only about 6,000 kilometers above Mars's surface. It's very close. So actually, when I thought that I did this, and it's just a little tiny rock, I thought that when I did this, it would actually just make them collide. So I go into Phobos here to its radius. See, it's only got a radius of 11 kilometers. And we are going to switch that to one radius of the moon, of Earth's moon. Boom. And like I said, I did this in the short, but I cut a lot of it out, and it's actually really cool how it all happened. So you can see it immediately gets ripped and shredded, but it does not completely rip apart, which interested me. I thought that adding all of that gravity, I really thought that it would get totally ripped apart, but it did not. So it actually makes Mars more habitable. So while I'm waiting for this, so when I did this weekend, basically it'll make a giant dust belt and then it'll make Earth a little bit colder. But I figured since I'm doing it again, I'm also going to double the size of our moon. So we've got the radius here. We'll just go ×2. So now we're going to have an extra large moon for the Earth. And we're just going to kind of turn the speed up here. I've got a much faster computer now, so I can actually simulate the stuff at relatively decent speed. Welcome. Hello, everybody. Thanks for joining. Thanks for watching me smash the universe to pieces. I said I actually thought this would totally destroy Phobos, but it's not going to, interestingly enough. We're going to really speed it up here. Let this dust cloud spread. And then I'm just going to cover my whole screen here. I'm going to let this rock for just a second because I know this is going to take a little while. So I'm going to let it go all the way to like, I went to almost 2100 on the weekend, but we'll let it rock for a while. We're going to go to at least 2150 and then we will see how habitable Mars gets. Hey, Bale, what's up? I'm just letting this rock for a little bit. I just decided to randomly hop on today because the short that I did this weekend I really liked, and this is basically what I ended up doing. So let's take a look here. So now it's 2035, so I've gone about 35 years. So we made Mars's moon the size of our moon. And in this version, I'm not getting as much habitability. I will show you, when I'm done, I'll show you what I got last time I did it. It is interesting how you can do the same thing and get different effects sometimes. And let's see how Earth is looking. Yeah, Earth's got a lot colder already. A lot colder. Pretty much ice covering the whole northern hemisphere here. Let's see, North America. Yeah. Just a lot colder. Alright, let's let it rock. What do you guys think would happen if our moon got bigger? I mean, I know the tides would be totally wild. And then, I said, hopefully I get the same result here, but if I don't, I did record the whole thing, so I'll show you guys what happened. But last time I made, when I did this weekend, just making Phobos the size of our moon essentially made Mars habitable because of all the extra material that it gave it. So it doesn't seem like we're getting as much warming this time. Let's see. Is it still warming up? It appears that it is still warming up, so we'll let it rock for a little bit. I've noticed that the level you zoom at allows you to simulate faster, so if you're zoomed way out, it's trying to render a lot more stuff. Yeah, that's not as cool. Alright, you know what? Let's make Phobos even bigger. Let's make it 2 masses of the moon. Or 2 radius of the moon. That's crazy, even though I made it 1 radius of the moon, but that's how much material it spit off. It spit off almost half of its material. So let's make it 1.5 radiuses of the moon. Uh-oh. I think they might just straight crash into each other now, but let's see. Let's slow it down a lot. What do you think? Oh yeah, we're gonna collide. We're gonna collide. So at 1 mass of the moon, it'll, or one radius of our moon, it'll stay in orbit, but 1.5, nope. Oh, it's getting so close. Maybe it will actually stay in orbit for a little bit. Are you serious? It's actually not gonna collide yet? Come on. If it actually doesn't collide, that would be wild. Could you imagine having a moon that big? Some constant eclipses, like daily eclipses almost. Constant threat looming overhead that this moon is just gonna fall on you any day. Alright, I guess it's not gonna crash. I don't believe that. Really? Let's see if this will make Mars habitable, though, with all that extra heat it's adding. All the tidal stresses and tidal forces. These are my favorite shirts, by the way. It belonged to my late father. It's one of my favorite memories of him. He had a good sense of humor. And, you know, if you're out there, if you still got your parents, make sure you cherish them. If you're lucky enough to have that relationship. Should we keep making our moon bigger, too? I think we should. So let's see. Right now, our moon is about 2 radiuses of the moon, so let's make it 4 radiuses of the moon. Boop. I wonder what that is as far as, So the moon is actually larger than Earth now, but less massive. So we'll see. We'll see if they eventually turn into like a binary pair here. And speed this up a little bit more. Look at Mars with our giant Phobos. And it still hasn't collided. That's totally wild. Alright, speed it back up a little bit more. Alright, there's our Mars. Now we're getting our lakes. Now we're heating up. There we go. That's what I'm talking about, baby. Yes. We're getting our northern ocean. We're getting more clouds. Look at that. We should be getting our southern lakes. Yep. Hey, kitty. And this is pretty much what Mars would look like if it did warm up. We know, you know, the northern part of it is a lot lower, and the southern part of it is a lot higher. So you would basically have a giant northern ocean. Let's take a look here. Wow, this is even better looking than the last time. Look at that. I'm gonna turn on the flashlight here for just a quick second. Yeah, look at that. It's kind of wild sometimes when I'm trying to terraform Mars, I have trouble, and then when I do something that I think would absolutely destroy it, it works great. I mean, just look at how close in this moon is, but it's transferred more materials over to Mars to give it more of an atmosphere. It's heated it up with all the tidal stresses, and so we've got lakes and oceans now. Alright, I'll turn that flashlight back off. Let's go back to the Earth. We'll see how we're doing with our moon that is 4 times bigger than it's supposed to be. And we have a giant dust cloud that's cooling us down as well. So our temperature is still creeping down, 39 degrees Fahrenheit on average. Turn this flashlight back on here. Oh yeah, look, all of North America is starting to get ice aged again. How's Europe doing? Oh, sorry, Nordic countries, you're not super habitable anymore. Trump doesn't want Greenland anymore. It's just an ice sheet again. Alright. Speed it on up. I got a few more minutes here before I gotta take off. Let me know down below if you guys have any questions, suggestions. Why does the Earth look so dull? I don't know. What do you mean? Usually when I do my shorts, I will actually put filters and things like that on. I brighten up the background and all of that kind of stuff. You can do different background colors and things like that. I kind of like the red one, actually. Makes it a little cooler looking. But we have a lot of dust. That might be what you're referring to, because when I made Phobos bigger and put it around Mars, it's just created a giant dust cloud here, so everything's cooling down. We solved the 3-body problem. So I actually did something similar to that. I don't have too much time left, but here I'll jump into they actually have the 3-body problem built into here, and I did an episode on this if you just search it on my channel, but I'll kind of do a quick recap. So so the 3-body problem, the TV show, is based on obviously a real problem, right? So where is, hold on, Proxima Centauri. I want the whole Alpha Centauri system. Yeah. Okay. So this is the Alpha Centauri triple star system. So as far as we know, in real life, generally when there are 3 bodies, the way that the 3-body problem sort of solves itself is you will generally have two objects orbiting each other and then one object orbiting very, very far out, right? So Alpha Centauri A and B orbit each other. They have a shared barycenter, and they're very similar in mass. And then when you zoom way, way out, Proxima Centauri, which is way smaller, orbits both of them. So the only reason we kind of think systems like this are stable is that they pair off. So generally when you have a trinary system, you're going to have two orbiting each other and then one orbiting really far out. If you have a quadrary system, you're going to have two binary pairs and those two binary pairs orbiting each other, right? So then what they did in the three-body problem is they basically slightly altered the Alpha Centauri system. So it is based on the Alpha Centauri system. But what they did is they kind of threw a bunch of random planets in and made it a little bit more wild, right? So we obviously don't know about all the planets in the Proxima Centauri system, but, you know, we know for sure that it could be pretty wild. So in the book, basically what happens is they're on one of these planets and they're constantly coming closer to both of the stars, because if you think about it, right, there would be times in your orbit, if you could manage to get into a stable orbit, there would be times in your orbit where you would have two stars in the sky during the day and none at night. There'd be times during the orbit where Proxima Centauri would be around the backside and you would have a constant twilight, right? So you would never have kind of like consistent day and night cycles like we have. And we don't know what that would mean for nature, but we just know it would be absolutely crazy, you know, and that it would make, like, we know that on Earth, things kind of take a long time to evolve. And how would that affect things if you have constantly changing solar dynamics where you're having way hotter days and then all of a sudden maybe 10,000 years later it's way cooler days, you know, all based on the dynamics of this system. And then, you know, imagine if you're a planet that's just orbiting Alpha Centauri A or just orbiting Alpha Centauri B. You know, so if you're in this little zone over here, then you're really going to have problems where, you know, like I said, you have basically no nighttime. You'd have Alpha Centauri A on the backside lighting you up during nighttime. So, but like I said, to basically solve the three-body problem, if you will, things need to pair off into binary pairs. So here I will kind of create, we'll try to create like a six-body system here, or a four-body system at least. So if we were to just kind of take random stars, oh, that's way too big. We'll try to make them kind of similar in size. Jeez. Okay. They're not going to be perfectly similar in size. So we'll put like these two close to each other. And then we'll put another binary pair here. I haven't done this in a while, so if it totally messes up, it is what it is. So we'll put another star here orbiting Serius B. And then we'll try to take, let's see, let's take Proxima Centauri here. And we'll try to go around all of them. So this will be like a five-body system. So we'll have two binary pairs. And let's see if they crash or not. I think if I set them far enough out like that, we should be okay. Let's see. It's going to take a while for us to see any sort of orbital trails here. They might just suck into each other. Like I said, it's going to depend on the dominant mass, whichever body has the most dominant mass. Like I said, you should see these two are kind of pairing off in a binary pair. These two are pairing off in a binary pair. And then the question is, yeah, I don't know if I made Proxima close enough. So let's see if we can auto-orbit it. I don't know if that's going to do much. And I might have set them too far apart, but like I said, this is the general idea. And we do have quite a lot of, I think we've observed star systems up to like 7 bodies that seem relatively stable. Now, how long they stay stable for, That we're not totally sure of because obviously we have limited observation time, and you know, we can go back in time as much as we want and try to, but you know, the fact of the matter is we only have so much observation right now. So is Proxima? I think Proxima's just gonna fly, but I wonder if these two will go into I'm just gonna go really fast. We'll see if they collide at all or if they're gonna get stable. Oh yeah. See? So now you have these two binary pairs orbiting each other. Like I said, Proxima might get flung out, but nonetheless, I think that's how we solve the three-body problem, is that nature really likes pairs. All right, before I get out of here, I'll add another sun to our solar system. Tootsie Zombie. Tootsies? Tootsie Zombie? Yeah, cool. I like that name. So I have done this before. I would recommend to go and search for it if you want to, but I'll do a quick one here. Let's do... We'll do Serious because it's pretty big. This should really actually roast everything. The sun might just get sucked into it. Let's see. Try to put it far enough away that they should orbit each other. All right. Mercury's gone. Maybe Mercury will live. Super hot though. Yeah, Mercury's... I think Mercury's making its exit. It bossed too close to the sun. Sorry. See how Earth's doing. We're getting colder because they're traveling away from us. It looks like the mass of Sirius is taking everything this way, but look, it's also bending our orbit. So it should continue to take us closer. Let's see here. How's Jupiter doing? We don't know where Jupiter's gonna go. You'd think we'd start seeing some of the moons of Jupiter and Saturn do some crazy stuff. Let's see. But the inner planets are totally getting rocked right now, because Sirius just made our sun start traveling. So we'll see what stays with it and what flies away. What time is it? 6:10. I gotta get out of here in about 5 minutes. Thank you everybody so much for joining and learning with me. Let me know what kind of ideas you like to see for shorts. Let me know what you're interested in space news. Yeah, Mercury's... I don't know where it went. It's gone. It must have flown into something, yeah. Oh, there goes Mars. But hey, at least it got an ocean before it got flung out, you know? 2 oceans, holy crikey. Yeah, Mars just needs to get warmer, guys. Let's just knock something into it and make it a moon of Earth. I'm kidding. Can you imagine if we actually had the power to do this stuff in real life and we had some politician like, hey guys, you know, maybe we should just change the orbit of these planets a little bit and make Phobos twice as big. Oh no. I hope Earth stays in orbit. Are we gonna keep any planets in orbit? I don't know. Venus. Venus is doing okay. I like how the speed is just glitching out here. It's always interesting when it's like trying to calculate the orbit and it doesn't know what it's going to do. It's like, I don't know what's going on. Oh yeah, Saturn and Jupiter, they're going a little crazy. I'm surprised we still have... Probably because everything was a little farther away, so Jupiter was able to stay gravitationally dominant, but Saturn appears to actually be following Sirius, but Jupiter not really. Let's see. Yeah, make sure to check out some of my other Universe Sandbox videos. Let me know how the quality looks on this. I'm doing it live, so unfortunately the bitrate of my internet is going to affect the quality a little bit, but when I upload videos that I make here, they're going to be super, super crisp. It looks so much nicer on my computer now. I was running a computer before that could barely handle this. I don't know how it did, actually. But yeah, so there you go. You add in a lot more mass, and we're just going to be toast. And as always, let's do a supernova to end this all off. Yeah, let me know what you guys are interested in as far as space news. We had a lot of Artemis updates and stuff that I just covered 2 days ago. Let me know if you're excited to go back to the moon, if you think it's kind of a worthless endeavor, if you think it's not that impressive because we did it 50 years ago. Yeah, Venus is always getting cooked, man. Really, you gotta move, if you want to make Venus habitable, you have to kind of move it out to where Earth is and just reduce some of its atmosphere. Or you can even keep it where it is, I think, and reduce some of its atmosphere. Which is very interesting, and it makes you wonder if Venus or Mars ever were habitable at a time, you know? Oh boy, Beetlejuice. No, he's too big. He's gonna ruin everything. Alright, let's see. A couple more stars. Algol? Sure, why not? It's a pretty big one. Clint Capella. Arcturus. Regulus. Alright. It's supernova time. Dun, 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 dun. Slow this way down. Boom. Ow, my eyes. That is so bright. All right, well, thank you so much for joining, everybody. Make sure to check out my other Universe Sandbox videos. Make sure to check out my space news. That's basically all I do here. We talk about space. We simulate space. Sometimes I talk about a little bit about Earth sciences, but other than that, like I said, thank you for jumping in. I got to get out of here, but feel free to leave other suggestions and comments on other videos. I always try to, when I see suggestions, I always try to write them down in my notebook. I might not get to them right away, but you know, if it's a decent idea. This was actually a user recommendation. One of my TikTok users, he was like, make Mars's moon the size of our moon. So a lot of times some of the best ideas are the ones that I get from you guys. So I said thank you for, oh, we still got planets. Let's let the planets get eaten. Bye-bye. Saturn, all of this stuff's just gonna get absorbed into the supernova.